Good morning. Our problem statement ID is SH1773. Our problem statement title is Conversion of 2D Blueprints in 3D Model. A theme is Smart Automation. Problem statement category is Software and the team ID is 11093. Let's start. So our proposed solution is to create a 2D to 3D conversion software. This converts 2D blueprint into 3D interactive walkthrough models. Improved flexibility is this can include 2D blueprints or user drawings to make this 3D model. This process is completely automated because it extracts all the features. How this addresses the current problem. So this enhances operational efficiency by providing clear 3D visualization for a better visual appearances, and this gives an accurate representation better than drawings or anything ever could. This is a unique problem statement because this reduces manual input by a lot. This runs on the system itself, so it has offline compatibility, and this is adaptable to be situated in any scenarios. So let's see other technologies. In technology, it uses Python 3 as a programming language. It uses Blender API to connect to Blender or to the Blender software. You can just change the Blender API into a AutoCAD API also. Then you can convert this from blueprints to directly AutoCAD drawings quite easily. Now let's go to a framework. We are using OpenCV for processing 2D images, and this is going to do processing and analysis of 2D images. Blender is a 3D modeling and rendering engine that we are going to use in our problem statements, and Tesseract OCR for scanning the drawings itself. Uh, but let's first ask us the question, why the hell are we using Blender itself? There are other softwares such as AutoCAD, Fusion 360, etc. But the thing of Blender is that it's extremely adaptable and it's free and open source. So you can use Blender to do animations, you can do Blender to do 3D modeling, you can use Blender for sprite generation, you can even use it to do computer aided machining or CAM. Now let's go to our hardware. For CPU, you just need a 64-bit dual core with SSD to support anything above the third generation Intel i5 can do this. For RAM, we need 8 gigs of DDR3. Storage 1 GB is enough, and GPU you can use integrated if you are just doing static rendering, and if you need dynamic rendering, you can use something like GTX 960 or R9 280 by AMD for live rendering. If you want a higher polygon count, maybe you can use something like uh, an RTX 3060 chipset. So let's go through our walkthrough basically. First, we are going to use a 2D sketch. This we are going to convert into a digitized image by using OpenCV. By using Shapely, we are going to convert it into different shapes. Then using PyVista, we are going to convert it into 3D polygons. This polygons will be stored by PyColada in XML with all the polygon data, and by using Blender Py or by using AutoCAD API, we can convert into a 3D image both in Blender or AutoCAD primarily, but we are still focusing on Blender itself. Let's go to feasibility and viability. Technical feasibility. OpenCV and Blender are proven tools, so no issues with that. We are going to have operational feasibility. As this is offline functionality, there is no need for internet. This can be used on site or can be used on any computer, no issues, and may run on moderately powered hardware. Any computer from the last 5 years can run this program with no issues whatsoever. Let's go to our potential challenges. Since we are doing 2D to 3D conversion, there may be some inaccuracy for detecting low quality blueprints. And if you are using larger buildings with more details and you are doing something like live rendering and all, there may be a processing hit with lower end hardware. Now let's go to strategies of overcoming these challenges. Blueprint accuracy. We are going to have a manual override on the Blender software itself that can change the sprite sizes, sprite shapes, etc. if there is something issue with our software to enhance the detection of doors, windows, and rooms. Performance optimization, we can just use reduce subdivide to reduce polygon count in 3D models. This may improve the rendering speed. We can also use progressive rendering to allow walkthrough to load gradually, reducing wait times. This is how rendering textures in games usually work from the 2000s and whatsoever. Let's go to our impact and benefits. This increase the sprite generation speed from around 3 days to 30 minutes. This has the ability to generate CNC compatible code with G and M code. We can have better client communication with the simplified complex design for easier client understanding, so that the client can uh, have better communication with the engineer itself. The engineer can show them the diagrams on the spot itself. And as I've said, this enables on spot modification on the final design. Let's go to animations and designing. Use of Blender has the potential to convert drawings into computer sprites and create computer animations. This is another use of our software, that Blender is used very commonly in computer animations and filmography whatsoever. This can also create dot blend objects which are 3D sprites. This can be used in different projects. So for example, if you want to do a lighthouse booth, you can use our software and incorporate them into a cinema project, etc. And let's finally go to virtual reality. Since VR is becoming more and more predominant in our life, we can use this to create 3D sprites in virtual reality software. We can also make a toolkit for existing software such as Vision Pro or Oculus. Now let's go to research. These are our research papers that we have referred, and thank you.